Fine, now before seeing about advanced topics like addressing modes, all these things, let's see some basic introduction. Okay, let's see some basic introduction like what is an instruction, what is an instruction set, all these things. See, whatever we have seen till now in computer organization and architecture has been a little bit easier, right? These topics has been a lot easier than the topics which we are about to see. Okay, whatever topics we are going to see hereafter is very important. Also, they are slightly difficult. Okay, and also at the very end of the course we will be seeing a topic called as pipelining, okay, which is a very important topic. Now in order to understand the concept of pipelining, you need to understand each and every concept I am going to teach you from now on. Okay, so please pay more attention so that it will be easier when we are seeing about a topic called pipelining, okay, which we will see at the end of the course. Fine. Now before that, what is meant by an instruction? Okay, let's understand what do we mean by an instruction. See, there are three types of programs. Okay, there are three types of programs. One thing is high level code. One thing is high level code. Also, we have something called assembly code. Also, we have something called assembly code. Also, we have something called as machine code. Okay, we have something called machine code. Now, why do we have these three types of programs instead of having only one program? Okay, let's see that. See, high level code is nothing but programs which application developers actually use in order to build a software, right? In order to build a software. For example, we use languages like C, C++, Java, Python, whatever languages you take which we are programming these days, they are nothing but high level code. Okay, they are nothing but high level code. Now any company, any software company you take, they are actually building softwares using this high level code. Okay, using this high level code. Now let me take a small example. So let me take a small line of code just to explain the difference between these three types of codes. Okay, so let me take a line of code, something like C equal to A plus B. Okay, C equal to A plus B. Now this line can be present in any language, C, C++, Java, whatever. Okay, I'm not following the exact syntax. Fine. Now we also have something called as assembly code. Okay, we have something called assembly code. Now how will I convert this high level code into assembly code? Okay, high level code into assembly code. Again, it totally depends on the implementation we are following. Okay, there are different types of processes, and depending on the processor, this code can completely change. Okay, so you don't need to by heart the syntax, but try to understand on what I'm doing here. Okay, so what I'm going to do is, see, this A, B, C, all of them are variables, right? All of them are variables. If you take the RAM, this is our RAM, and we should have stored the value of A over here. Also, we should have stored the value of B somewhere over here. Also, we should have stored variable C somewhere over here. Okay, now what we will be doing is we will be taking this value of A and then I will be placing it inside CPU registers. Okay, CPU will be having lot of registers. So these registers we can also say them as general purpose registers. So now what I'm going to do is I'm going to take the value of A and then I'm going to place it in the register. Okay, and I'm going to take the value of B and then I'm going to place it in this register. Now I'm going to add both these register values and I'm going to store the result in this register. Okay, after that I will be taking this value and then I will be placing it over here. Okay, that is how I'm going to do this operation. Okay, this operation. Now you might ask me a question on why are we really moving the value of A and B into a register? Can we directly add the value of A and B and place it in C? You might ask me a question. Anyway, I will come back to this point a bit later. Okay, let's first see the assembly code on what I have told so far. So first I'm going to take the value of A. So let me take the value of A as 6. Okay, something like 6. Let me take the value of B as 7. Okay, now what I'm going to do is, see, now what's the value of C? It can have any value, it doesn't really matter. Okay, fine. So I'm going to load the value of A in register R1. Okay, in register R1. Again, you don't need to by heart this syntax. It can totally change depending on the implementation. Okay, instead of using load A comma R1, I can write something like LD A comma R1. or I can write something like LAD A comma R1 or LOD A comma R1. I can follow any syntax. Even I can change the parameters, which means instead of writing load A comma R1, I can definitely write load R1 comma A. Okay, there is nothing wrong in it. Now, how will I understand what do we really mean by this instruction? See, one thing is that we don't have a rule while writing these assembly instructions. Instead of writing load A comma R1, I could have written it something like load R1 comma A. This is not wrong. This is also fine. Okay. Now, what's the difference between both these instructions? See, here we are taking the value of A and I'm going to place it in register R1. Okay, I'm going to place it in register R1. Now, instead of, for this exact process, I can either write this instruction or this instruction. Both are correct. Now, on seeing this instruction, what you will really understand? Should I take the value of A and place it in R1, or should I take the value of R1 and place it in A? Right? You might get a confusion. Now, in order to avoid these confusions, we use something called as commands. Okay, commands, where they will be specifying exactly on what we are going to do with this instruction. Okay, whether I should take the value of A and place it in register R1, or I should take the value of register R1 and place it in variable A. Okay, that will be clearly mentioned using commands. Okay, using commands. And see, in exam, they might give you an assembly code and they will ask you to find out the output of this assembly code. Okay, now for that they should have followed different syntaxes, right? So we cannot get the exact information about this instruction using this. For that we use something called as commands, right? For every instruction they need to definitely mention on what they are doing using the syntax inside the commands. Okay, so commands are very, very important. So that's why I told you that don't need to by heart the exact syntax. It can completely change depending on what implementation we are following. Okay, fine. So let me erase this. Fine. So I have written the instruction load A comma R1 and I have mentioned that this instruction really means this. Okay, using commands. Fine. Now I am going to load the value of B in register R2. Okay, load the value of B in register R2. So load B comma register R2. Okay. Again, here also you can mention what we really mean by this instruction in the commands. Okay, you can simply write it. So I'm going to say it in words. Okay, you can simply write it, which means load the value of B in register R2. Okay, fine. Now I'm going to add the value of register R1 and register R2. Okay, add R1, R2, R3. Again, there is a small confusion over here. Should I add the value of R1 and R2 and place it in register R3? Or should I add R2 and R3 and should I place the result in register R1? Again, there is a confusion, right? Again, there is no standard notation. It can totally change depending on implementation, which means whether should I add first two operands and store the result in third operand, or whether I should add last two operands and store the result in first operand. There is no standard implementation. Okay, so to avoid the confusion, they need to definitely mention what they mean by this instruction in commands. Okay, where they will clearly specify that R3 is going to hold the added value of R1 and R2. Okay, they will mention it in the commands. Fine. Now I have placed the result in R3, register R3. Fine. Now obviously I need to store that value back into the variable C. Right. So what I'm going to do is I'm going to use store R3 comma C. Right. Store R3 comma C. Fine. Again, I will be mentioning exactly that. I will be storing the value of register R3 in C. Okay, in C. See, again, you might get a confusion on what's the difference between load and store, right? See, we have different levels of memory like hard disk, RAM, cache memory and register. In case if I'm moving the data from slower memory to faster memory, something like moving the data from RAM to register, then we say it as loading. Okay, whereas in case if I'm moving the data from faster memory to slower memory, something like register to RAM, then we say it as storing. Okay, that's the difference between loading and storing. Again, these are not standard terminologies. I can still use the term load instead of store over here. Okay, but in most of the textbooks, this is the terminology they are following. By loading, they mean moving the data from slower memory to faster memory, and by storing, they mean moving the data from faster memory to slower memory. Okay, again, it can vary depending on implementation. These are not standard terminologies. Fine.